Okay. So what we're gonna be working on for the next several weeks is something that is gonna allow us to investigate forces. And I mentioned the other day what forces are. I'm just gonna mention it again because the reality is that that you probably can't hear this kind of stuff enough. The main purpose of what we're gonna talk about this morning is just to give you an idea of what the project itself is going to look like. So we don't have to worry too much right now about the content, but for those of you who like to think about this stuff, there's going to be two big things to work on. One that everybody's going to work on, and one that's optional. The one that everybody is going to work on is forces. You don't need to write this down. This will show up in the recording, and you'll have an opportunity to write this kind of stuff down later as well. Forces are really easy to describe in words. Forces are just pushes and pulls. We feel forces all the time. We exert forces on things all the time. And so one of the things that's really kind of interesting about forces is we know what they are. Like we can talk about like pushing and pulling and stuff like that. What's really interesting about forces is what they do. And it turns out that forces have the potential to change the motion of an object. So we're going to be investigating a couple of things. One is what are forces and what kinds of forces are there out there? What are the forces that are commonly acting on things that we are interacting with? And how do they affect motion? And if you think about it, we've already looked at motion. We talked about things like position, which is where something is, and displacement, which is when something moves. And we talked about velocity, which is how quickly something is going. Dean and Emma. And so we talked about how forces affect motion, we talked about motion itself, and now we're going to talk about how forces affect motion. So what forces are going to do is they're going to change where something is or how quickly it's moving. They're going to affect the things that we've already looked at. And that's all we really need to think about forces for now. We're going to look in much more detail at this and doing some calculations and predictions and stuff like this. The other thing that we're going to think about, and this is the piece that's going to be optional, is there are these really cool little devices called Arduinos. And I think I have one in here. This is an Arduino right here. And they call them controllers. But really, what this is it's a computer. This is a computer. And it's not a very fancy one. But it's a computer that is designed to allow you to communicate with the device and then have the device cause things to happen. What we're going to do specifically is we're going to have something hooked up to this Arduino that can detect a force. We're going to detect a force with the Arduino, and then you're going to make the Arduino do something as a result of that. And the something that you do might be it might make a sound, it might play a song, it might move something with a motor. There's all sorts of stuff that we can make the Arduino do. The Arduino is a controller that we can program and we're going to program it to respond to a force. And this is going to be optional. And the way that we're going to set this up is for those of you who either just have no interest in like this kind of stuff, that's fine. Or for those of you who are going to really have your hands full just thinking about forces, that's fine as well. You don't have to do the Arduino thing. But if you're targeting an A in the class, and many of you are, and you should be because you can do it, then this is going to be required. If you want A's, we're going to ask you to kind of do a next level of work that is more involved, that's going to require more commitment, more of an effort, and more of a demonstration of understanding on your part. Those of you who are perfectly okay getting a C, maybe a B, you don't have to worry about the Arduino stuff. We would like to challenge those of you who really are interested in being challenged, and we would like to make sure that everybody here has a pathway to success. Everybody here has a pathway to passing the class simply by sticking to our tried and true framework of being here, using your class time, and turning stuff in. That'll get you a C. You want more than a C, you're gonna have to start doing some of this extra stuff that's gonna be a little bit more involved. The project that we're going to be working on, where we're going to be exploring forces and using the Arduino, is the marble machine. And last week, you all were working on simple machines. You worked to build 3 simple machines, 1 lever, 1 ramp, 1 pulley. The idea was that ultimately you were going to be able to use those 3 simple machines in this larger project, which you're going to begin today. And the way it's going to work is your marble machine is going to have a marble, and the marble is going to move from one corner of your machine to the other corner of your machine. And there are a couple tricky things that we're going to ask. One is that your machine needs to run for at least 10 seconds. So that is like, well, 10 seconds is nothing, except when you're actually moving a marble from one corner of a relatively small piece of wood to the other corner, what you're going to find is 10 seconds actually is kind of a long time. Like most of the time, if things move this far, it happens in much less than 10 seconds. So one of the things that you're going to be needing to do with the simple machines that you build is slow your marble down, right? If you just build a ramp from one corner to the other, it's just going to go in maybe a second at the most. And the marble itself is going to be mostly kind of moved along by gravity, but it also, you could potentially build in some springs or rubber bands or other things to kind of change the motion of it, to give it a little bit more oomph, but it's not going to primarily be driven by that sort of thing. And potentially you could use your Arduino as part of a propulsion thing, like your Arduino could move the marble, or there's a whole bunch of things you could do, and what we'd like is for it to be fun and challenging for you. So we're going to not place too many limitations on kind of like what your machine looks like, because we would like for it to be fun. Mainly what we're trying to do is make sure that you understand that this needs to be a challenge. So it's not going to be just like a wind-up motor where you put your marble in it and then let go, and then it like drives your marble slowly across the device. Like anybody can do that. We're looking for you to build something that challenges you. You have about 16 inches of height to work with. So we told you before that the base itself is going to be 16 by 16, but the whole thing needs to be able to fit into a box, right? So if your marble machine kind of looks like this, and you have like some stuff here, and it goes down here, and it goes over here, and then it goes there, and there's a pulley here, and a wheel here, and an Arduino here, and something else, and then it ends up right here, the whole thing needs to be able to fit into a box that is 16 by 16 by 16. And partially, that's just a function of the fact that that we have limited cabinet space. So if you build yours bigger than this, like the way I drew this, that's not going to work, right? I need to make I need to make sure that it fits. So if you build it bigger than 16 inches in any direction, it won't fit in the cabinet. So we've got to make sure that that's covered. Your marble needs to do something when it's all done. That could involve the Arduino for those of you who want to have an Arduino as part of your machine. So you can have the marble trigger an Arduino, and then it plays a song, or turns on some lights or something. Or if you don't want to mess around with the Arduino, that's fine. You can also have it just do something that like is purely mechanical. We sometimes the marble will like turn on a light switch, and that's fine. Or one really easy thing is to build a lever at the end and have it like pull a piece of Kleenex out of a box or something. And all of those things they're not there because we actually need to accomplish the task. They're there just because it's kind of fun to think about something like that. We've had students pop a balloon. We've had, like light a candle. There's all sorts of things that it can do. Your marble machine needs to have at least 6 simple machines. You should already have 3, and you need to build another one, another set. 2 ramps, 2 levers, 2 pulleys. And then the Arduino, we'll talk about down the road for those of you who are interested. It needs to activate a sensor that detects force. That's called a piezoelectric sensor, or just sometimes people just call it a piezo sensor. So those can detect forces. They're pressure sensors, basically. And we use pressure sensors all the time, like switches and stuff like that are basically pressure sensors. And then you just need to understand that the goal of the Arduino is for it to do something else. And the Arduino could be in the middle of your marble machine. It could like lift the marble back up a little bit, or it could be at the end, and it could be kind of the final, the ultimate task of your marble machine might be to turn on some LED lights by using the Arduino. This is individual. And so I want to just make sure that everybody understands what that means. There are some of you who are, you're still kind of getting a feel for how things go in the shop, and that's okay. But what we would like is for you to recognize that everybody here can do the work that we're asking you to do. So if you're still not comfortable with the machines, or you don't know how to do something, you should ask one of the instructional team. Don't ask each other, because all of you have your own marble machine that you need to build, and your job is to work on your own machine, not to help other people with their machines. So we're the helpers, and you all are working on your own machines. We know that those of you who are a little uncomfortable with the machines will get it. Just in case you feel like sometimes that's something that is a little embarrassing. And I will tell you that after 24 years of doing shop stuff, I still am nervous. Those machines are intimidating to me. Many of you are far less intimidated by the machines than I am. When I first started teaching this class 24 years ago, I didn't know how to use any of this stuff. I didn't know how to use any of the machines in the shop. Like, I knew how to use hand drills and stuff, but I had never used a drill press. I'd never used the bandsaw. I'd never used a table saw. None of that stuff, ever. Which means I had to have the shop teacher at that time show me everything. He had to show me everything, and then there would be a lot of things, like cutting the wheels out of the wood, just like you all did. Like, that was something that I was really nervous about. So if you're feeling a little uncomfortable with the machines, understand, I can relate. And the fact that I can do all this stuff now is proof that you can do it too, because I was just as uncomfortable as you were when I started. And then we're gonna have you with your machines. We're gonna have you, just like we did with the Derby Racer, making measurements. We're gonna have you, Alex, will you move just one row back, please? We're gonna have you making measurements, and we're gonna have you reporting some data. We're gonna have you doing some work with your marble machine. So there's a couple things to think about with that. Number one, your marble machine should work. And what happened with the Derby Racers is those of you who used your time really well, for the most part, got a Derby Racer that worked. Some of you didn't get through the safety tests in time to really build a Derby Racer, and we get it, but everybody's good on the safety tests now. And then the other piece is that if you are taking a long time to build your marble machine, it's not going to get done, and it's not going to work. So we're going to tell you how to do things more efficiently, and you have to do it that way. Not because it's necessarily going to be better than whatever you had in mind, but for example, I showed everybody here real quick how to build a ramp, a pulley, and a lever. And if you tried to go about it another way, and you ended up not getting your 3 simple machines done, there's a reason for that. And the reason is, you didn't do it the most efficient way. What I showed you will work. We can help you get it set up. None of it is hard. It's relatively quick. If you spend an entire hour trying to make one ramp, you're not doing it the most efficient way. So let us help you with that piece, because ideally what will happen is in a few weeks, everybody will have a really well-built working marble machine. And those of you who don't are gonna find that largely that's a product of inefficiently using your time in the shop. So part of what we all need to work on is making sure that we're like making progress, not just working, but actually making sufficient progress so that we can get this done in a reasonable amount of time. All right, I'm gonna shut the video off.